first of all, a very good evening to our respected speaker and all the participants who have joined us tonight, and hope you all are doing great. I'm Zahra Arif, and I'm so glad to present you our final session of this virtual talk series, which is brought to you by University of Bolton, Al-Khaimah, and it's in collaboration with the British Computing Society Middle East. So, firstly, I would like to extend a very warm welcome to all of you and appreciate you for choosing to be here tonight, for choosing to participate, as the main objective of this series was to share ideas, information, and of course, the best practices. So, as usual, before we begin today's program, I have a few notes to be considered. Firstly, I'd like to seek your cooperation to please make sure that your microphone and camera is off at all times during this session. And if you have, it's fine. But if you haven't already, please make sure to rename your usernames properly, your first name and your last name, as certificates of participation will be given out to the person who registered. So if you have any questions, note them down, keep them with you, because you will get the chance to ask them once the presentation is over. So now that's out of the way, we can begin. So as we all know, every age has its own scientific discoveries and inventions, right? But today's scientific advancements can impact globally in a very short time. Artificial intelligence, it's already having a very profound impact on the way we interact with the world. And it has very significant applications in many fields. And one such field is transport and road safety, transportation. It plays a major role in the daily life of human beings, right? And it's very necessary for us to move around, or for things to be moved around. And according to WHO, which is World Health Organization, just last year, basically road traffic injuries were the leading cause of death amongst children aged 5 to 14 and young adults aged 15 to 29. So this is quite overwhelming, considering that majority, if not all countries, they don't allow people under the age of 17 to practice driving. So what does this tell us? It tells us that out of the millions of people that have died in road incidents over the years, a large proportion of those were not even driving the car. So tonight, our honorable guest speaker will be discussing about how AI and LIDAR technology can improve road safety. So without further ado, I'd like to invite the session chair, who is Mr. Riasat Ali. He's Engineer Riasat Ali, the Group Head of IT at RAK Ports in Al-Khaimah, UAE. And he is currently leading the Digital Transformation Program at RAK Ports Group, encompassing the TOS, which is Terminal Operating System, Port Community System, and Integrated Maintenance Management System, along with IoT-based port equipment monitoring system as well. And he's also a fellow member of British Computing Society and a certified professional Scrum Master for Agile Framework. So please, Engineer Riasat, take away from me here.
Thank you very much, Zahra, for a very nice introduction, and welcome to all the participants and the honorable speaker of today's talk. It's a great pleasure to be here, and it's an honor for me to chair today's session, even though I can see a lot many doctors and professors on the panel here. But again, I would say British Computer Society, Middle East chapter, and University of Bolton, Ras Al Khaimah campus, as well as the other campuses, they are doing great in hosting these kind of programs. And they are really helping the community, especially the students here, as well as the business community, in getting the best information in such type of events and webinars. Artificial intelligence and LIDAR technology in road safety and security. This is the topic for today's webinar, and it will be led by Mr. Mohamed Sadek. But in order to welcome him, I would, we have Dr. Satya Shah, who is the Professor of Supply Chain and Engineering Management and Head of Global Logistics and Supply Chain Management Center at University of Bolton. He leads the design and development of the academic research and degree apprenticeship programs of logistics and supply chain at Bolton. Now, definitely there is a connection between today's topic and Dr. Satya's background because it's related to logistics and supply chain, and he will be also, uh, benefiting, or he will be throwing some light for others on how today's speaker can add value to all the participants' knowledge. Um, I think I will not take much longer on this, and I'll request Dr. Satya Shah to come forward and talk about the welcome note and invite Mr. Mohamed Sadek.
Hi, good evening, everyone. Thank you, Riasat, for a lovely introduction. My name is Satya Shah. I'm a professor and director of global logistics and supply chain at University of Bolton, and on behalf of University of Bolton at Bolton, UK, and that of Bolton RAK campus and all the colleagues at Bolton RAK, I welcome everyone, all the participants. At the present time, we have 113 participants who are currently within this webinar. The BCS webinar on AI and LIDAR technology in road safety and security. So it's my great privilege, and on behalf of University of Bolton, I would like to welcome Mr. Mohamed Sadek. It's unfortunate that we are meeting like this. We would have been meeting in person if these sessions were in a normal environment. We are now in the global pandemic and the new age of, I would say, evolution of technology. We all knew about technology. We all had adopted technology, but now we are benefiting on the usage of technology. So it's very rightful that we have these webinars. What can I say about Mr. Mohamed Sadek? A technologist, a software developer, an absolute gem in terms of his experience in telecoms industry. He's the founder and CEO of Com-iot Technologies, which is an AI, an artificial intelligence-based company in Dubai. His background has been more than 30 years in telecoms industry, educational background with a master's in computer science from University of Illinois in Chicago, and an MBA from Wharton Business School. And so, his entire career, I would say, he has worked right from software development at AT&T Labs. Those of you who are not the millennials would not really know the key contribution of AT&T Bell Labs during that time in terms of moving from analog to digital technologies and its immense value as a company and the work which they did in software development within the telecom sector. What we see in our mobile technologies right now had been pioneered by AT&T Labs very, very early on. So, it's a great aspect that we have a speaker who comes from those roots. Mr. Mohamed Sadek then went on and spent a lot of years in Lucent Technologies, Verizon Telecoms, to name a few. Again, very specific to telecoms as a sector, and his passion is continuing as we speak. And it's a demonstration that he is here today, sharing with all of us in terms of his passion on AI and the advantages of technologies. So once again, an immense pleasure in welcoming Mr. Mohamed Sadek, and I'll leave the floor open for him and Riasat Ali to chair the session. Please feel free, the participants, to write your questions in the chat window as we are progressing. I'm sure Mr. Mohamed Sadek will take the questions right at the end. And we welcome as much as discussion and collaboration going forward through this event. So without any further ado, I'll gracefully invite Mr. Mohamed Sadek to take the proceedings further. Thank you.
Thank you very much, sir. Appreciate the introduction and appreciate everyone's earlier messages. I also like to welcome you all to this program, which I hope will be both informative and enjoyable to all of us. Today, I will be speaking about the importance of LIDAR technology in the in today's environment, especially with regards to artificial intelligence applications. And I will focus a little bit on road safety applications and physical security applications. So without further ado, I want to speak about Com-iot's experience, because that's really where we contribute. The company has been formed about 4 years ago to specialize in artificial intelligence solutions. And then very early on, we came across the LIDAR technology, and we probably introduced the first sensor to the Middle East back then. And the picture that you're looking at includes a lot of cameras and a lot of LIDAR sensors made by different manufacturers. And the reason I have this picture is because that's what we use. We develop our AI algorithms with the use of these devices in mind. We fuse them together, and we fuse the AI solutions themselves into each other. And I will shed some light on how that is done. But what is LIDAR? A LIDAR is a device that emits laser beams in 360 degrees. Those laser beams rotate at a very high speed, continuously falling on objects in its way, measuring distances with such high precision, and all the depth of all the objects all around it, and come back to the receiver. And from that, distances are calculated. And with the time factor and the distance factor, you are able to have an output of a three-dimensional map of the environment. So just like a camera produces video streams, those videos are basically pictures lined up one after the other. We call them frames. Those are 2 dimensions. The same thing for LIDARs. It produces an output known as point cloud, and it from that it draws a 3-dimension map of the environment, because those beams are hitting the objects at different heights and at different depth. Then it is 3-dimension in its output in nature. This picture here shows the basic difference between cameras who have typically a field of view. You can zoom in and zoom out and change the field of view, as opposed to a LIDAR that has a total surrounding view. Again, we talk about the frames of cameras as 2 dimensions. So they are X and Y. You can basically zoom in and zoom out and perhaps enhance the image. Whereas in a LIDAR output, you have access to a lot more application given the 3rd dimension. So I will show you some examples of that. This picture here shows how LIDARs differ from cameras. LIDARs are not cameras. They don't have a lens. So they don't really depend on lighting condition or weather condition, whether there is a storm or rain or dust, indoor or outdoor, total darkness, etc. So from a complementary standpoint, LIDARs and cameras cover it all. So you have the 3-dimension map, and then you have the field of view in video streams coming from the camera. If you are able to get them to work together as one system, then you have it all made, and we will see how that works. Our company has 3 US patents for 3 of our inventions, and we're very proud of that. This solution here is deployed in on one of the highways in the UAE.
Mr. Mohammed, you're muted.
I think while playing the
Yeah,
video.
I may have muted myself. I apologize for that. I don't know how that happened, quite honestly. But I am showing you now a video that shows the power of camera alone. No LIDARs here. This is a video from YouTube. And it's a bad accident on a highway in the UK, unfortunately, so prepare yourself. This truck driver was busy and distracted on his cell phone, changing music, and he hit all these cars and caused a lot of unfortunate fatalities and tragic accidents. So what we in Com-iot did is this. We developed HORUS. HORUS is a solution that uses cameras and is deployed here in the UAE. And as you can see, this 1.5 second video that repeats itself shows that we are able to detect and track the car, detect and track the driver, and analyze the driver's behavior, resulting in this image here, where the driver is caught distracted on a cell phone. Distraction on cell phones causes 10 to 19% of all fatal accidents on roads and highways globally. So it's definitely a major problem everywhere. We all have seen it. Unfortunately, many of us continue to use the phones. My advice to you is put the phone down while you drive and wait until you are safe, and then answer or text or read your text. Or get out of the road, because otherwise you put your life and the lives of others in danger. So this is a distracted driver detection solution. And you can see here the system also, in this very brief fractions of a second, captures all the metadata associated with this violation. So the system can be deployed in a variety of ways on the roads or side streets. I want to show you, I'll probably show you, in the interest of time, I'll jump to TRC. Nowadays, there is something that is growing called ITS, Intelligent Transport System. Governments, municipalities, and authorities everywhere are trying to deploy intelligent systems on the road and the infrastructure, so that they can not only enforce the law and detect violations, but also collect data that is extremely valuable, that helps the authorities and road services companies improve services and prepare for future planning and better serve those on the road. So we developed HORUS TRC. TRC stands for Total Road Control. And it's a system also deployed in the UAE here, and is very unique in that it uses LIDARs and cameras and provides a lot of very valuable services. I'm going to walk you through some of these services very quickly to demonstrate the solution. Now, what we have here are cameras. These cameras are calibrated, synchronized, and configured with a LIDAR sensor on top of the unit, and they all work together. The cameras and the LIDAR are working in unison to achieve all of these objectives. First one is speed enforcement. We measure the speed of all cars on the road. Now, this is an old technology being done by Doppler radars and other traditional technology. But look how we do it with LIDARs. This is an actual output of LIDAR, is known as point cloud. And as you can see, it appears like it's a bird view, like it's taken from a drone. But because it's a 3D, it allows you to play with it this way. So not only can you zoom in and out like in a video frame, but also you have the third dimension to look through and have that kind of view. This is a 16-lane highway, 8 going north and 8 going south. Every vehicle is detected, is tracked, is given a unique ID, and its speed is measured with a precision of 6 fractions of a kilometer per hour. So this is what the power of LIDAR can do together with algorithms. The AI component here is the neural networks, layers and layers of convolutional neural networks that allow the system to understand and detect vehicles, trucks, buses, all sorts of vehicles on the road, and then be able to enhance that detection to the point of tracking them wherever they go. And then once you detect and track, you are able to then put a lot of applications on top of it. Here in this case, measuring the speed. Now, once you have the speed measured, you can do so many things. You can measure the average speed. You can do tailgating. Here is an example of also a LiDAR output. Tailgating is when the car in the back is driving too close to the car in the front. You have the speed of both cars. You have the distance between them measured by LiDAR with a precision of 1 centimeter. And from that, with a simple formula, you are able to detect a violation of tailgating. Now, when you detect a speeding violation or a tailgating violation, and because you have the cameras fused with the LiDAR is then able to tell the camera to take an image of the violating vehicle, and that becomes the evidence of the violation. These are images of the violating vehicles taken by the camera, instructed by the LiDARs, and produced on a dashboard at a command and control center with all the associated data. So you have the time stamp, the date, the speed, the lane number, etc. So all the information that you require. You also have a bounding box around the vehicle to allow for the license plate number to be read by an ALPR, automatic license plate recognition engine. So that's one of the ways of the services, the speed enforcement, the tailgating enforcement, accident recording. That's an interesting feature because we talked about LiDAR. Here you see the videos from the cameras, and you also see the LiDAR point cloud. As we know, cameras are two-dimensional. So if you have a truck like this blocking the way of the field of view of the camera, you cannot see what's going on behind the truck. So your video is useless in this case. Comes in the LiDAR, where you have a three-dimension. You can see the truck, you can see the lane before it, you can see the lane behind it, you can see all around it, you can zoom in and out to 1 centimeter precision, and you know exactly what is going on at all time without the chance of obstruction or occlusion. Now, we call this accident recording because this point cloud records everything. And when an accident happens, it would demonstrate which vehicle hit which other vehicle from which lane into other lane. Now, all the lanes are given unique IDs, and you get the angle, you get the coordinates. So the LiDAR allows you to get all those associated data. So you don't need any more accident investigation or taking statements from drivers or pointing fingers. He hit me, no, she hit me, etc. Because you have that fully recorded in 3 dimensions. And then walk you through some of the other services real quick. We have vehicle counting. Now, that's a road service that is extremely valuable. Governments and authorities always like to know how much traffic is on the road. This way, they can manage the road better. They can monitor traffic. They can better plan for future expansion, etc. And we use here, you can always count by video, by cameras. But the problem is obstruction again. So big cars will obstruct smaller cars behind them, and you will miss a lot of cars over time. Whereas, as we can see here in the LiDAR point cloud, when you draw a counting virtual line here, every vehicle can be counted with such 99.99% precision. So the counting can be done on one lane or for the whole road or for groups of lanes as desired. And as you can see here, this is accurate directional vehicle counting. Can you all hear me? Is everyone okay?
Yes, please proceed.
Sure. Then vehicle classification. LIDAR is able to measure distances and dimensions in 3 dimensions, like containers in a port or vehicles on the road. And with that precise measure of length, depth, distances, we are able to classify vehicles as large or small, trucks and buses, or all other types of cars. We also count them, we count them per lane. So classification of vehicles is also a very important feature. We detect shoulder driving because the shoulder on the road is just another lane, so no one is supposed to drive on it. So if we see someone by LIDAR, we can immediately issue a violation. Also the same thing, if somebody is driving on the road with the speed in the negative, that means they are in a wrong way violation, then a violation image is issued as the detection. Then because we measure all the speed of all the car all the time, we are able to get the average speed. And if the average speed reaches below half the speed limit, then we issue an alarm on the dashboard at the command center of a traffic congestion. If the average speed goes below down to 5 kilometers an hour down to 0, then we issue an alarm for traffic stoppage so that the authorities can take the necessary action with this valuable data reaching them. And then we can do that also per lane. And we can set the different speed limits for different lanes. In some countries, you would require that. And then accident detection. When you have one car reaching a speed of 0, that means it's car trouble or an accident. If 1 or 2 cars in 1 or 2 lanes, that will also be an accident, and an alarm will be sent to the authorities. The same thing for debris detection. Debris meaning a truck dropping some of its cargo, like boxes or other cargo, or maybe a car heading to the airport and carrying suitcases, and 1 or more drops on the road. The system will be able to detect non-vehicle objects on the road with lane number and coordinates, and will send an alert to the authorities in real time. So accident detection and debris detection are also 2 very valuable set of data gathered from the road and sent in real time to the authorities. These are some pictures of the units. The same units have been deployed on highway gantries like these. These are the images of a violation. Here is a dashboard in action where you see the violations are happening and the pictures are taken. What you have seen before is the inner working of the LIDAR causing all these images to be taken. For the police department, they only see this. They only see the pictures taken after a violation has been detected. But you now have seen what happened in the background all the way that led to these images becoming a reality. So a user-friendly graphic interface for the dashboard, and a beautiful thing. I want to also give you very briefly the Smart Patrol. The Smart Patrol is one of our unique innovation with a US patent. And this is a police car. By the way, just to show you here, in the interest of time, I'm trying to be quick, but these are the valuable data that are issued to the authorities on daily reports. They show in pie charts and bar charts and graphs all the information I've mentioned, the counting per lane and the counting of vehicles for the whole road. You see them, you see the average speed, the congestion indicators, you have these speed violations, very valuable data that are gathered all the time. And you know, they say data is the new oil. Here in this case, we see congestion indication. The traffic has slowed down to this point, and so forth. I'm going to jump to the smart police car. We developed a solution that we call P3, plug and play patrol. And we call it plug and play because it is very easy for a police officer to use. We have made it so easy that all a police officer needs to do is to touch the screen on the tablet on his dashboard, and the system just comes up. The system is basically LIDAR sensor and cameras that are connected, configured, synchronized, and calibrated with the LIDAR to work as one group. Just like we saw in TRC before, this P3 solution also does the same thing. Here is the US patent for the invention. It does speed enforcement, tailgating, distracted driver, and seat belt violation detection. This is an actual test. This is a point cloud, which is really the video of the LiDAR. And what you see in the middle of the circle here is the police car. And all those boxes are the cars around it. And the system detects the vehicles, track the vehicles, assigns a unique ID to every vehicle, places a bounding box around it, and measures its speed with high precision up to 6 fractions of a kilometer per hour. So here, the police officer needs to just focus on their own safety as they drive on the road, and the system takes care of it all by itself. Here is a more clarifying video. This is a real video from a real test. The police officer touches this green button for start P3, and the dashboard comes up, the LiDAR, the camera, the computer in the trunk, everything comes to life. The cameras are synchronized with the LiDAR. You can see the video stream from both cameras. The dashboard allows the officer to set the speed limit depending on the road, and then any car on the right or on the left caught above the speed limit will be captured by a video and an image with all the associated data, will be displayed on the dashboard and stored in the system for later retrieval. So these are the violations taken by a police car as it drives and patrol on the roads and highways. And if I can show you this picture here, there is another camera that is looking behind the patrol for drivers like this one here, who is without a seat. This driver here doesn't have a seat belt. And this driver here is distracted on the cell phone. So these images are taken to be stored and displayed on the dashboard along with the metadata as we have seen before. Now, radars are also used in road safety, but radars fail when they are used in a moving car. And this is from radars.com. They say that if you put a radar in a moving car, the failure rate is about 30%. What we have discovered is that the failure rate can actually reach 70%. And by failure, we mean if it detects 3 out of every 10 cars, then that would be a failure rate of 70%. Here are some other tests performed. This is also in Cairo with Cairo traffic. This is the radar, and this is the LiDAR. So that's just to clarify further all these electronics. Some of you may be hearing about them for the first time. Here is an image of a high resolution radar. It's a 2-dimension, very hazy. And here is a LiDAR image, a 3-dimension, much more crisp, and allows for much more precision. It works at night just as well with the help of IR technology. I want to touch base very quickly on this solution we call iSlope. This is also a LiDAR solution. In order for the governments and road services to avoid accidents like these, when you have a ditch or a steep slope on the side of the road, they have to build guardrails like those. You all have seen guardrails. Now, the way they build guardrails on the road is they identify where on the road is the slope too dangerous, too unsafe, too steep. And the way they do this today is they measure the slopes by clentometers like these. So they drive on the road, they get to the slope area, they come out of the car, they measure, and they take the coordinates of the location from a GPS tracker, and they mark the angle, and they drive back on the road. They stop again, they get out of the car, they measure again, so that they know where is the road, is the ditch unsafe, the slope unsafe, or where is it safe. Where it is unsafe, they decide to build a guardrail. This process can take several people, several weeks or months, depending on how long the roads are. What we have done is developed a solution that we call iSlope. And iSlope does automatic intelligent road slope measure by LIDAR. So all the companies needs to do is to have a driver driving on the road at full speed, doing absolutely nothing but focusing on their own safety as they drive. And by the time they arrive at the end of the road, they will have a report detailing all the angles with very high precision, with all the associated coordinates, placed in a file with all the alerts, all the thresholds, and all the data they require. So the work that would have taken many people, many months, can be done in just a few hours by one person. And in fact, if you have an autonomous vehicle, you wouldn't have anybody required. But that's another topic altogether. So iSlope saves a lot of cost for a lot of road companies. Now, this is, if I show you how also an image from this looks like, if this picture here, this is the real test. Obviously, the solution was sold to one of the regional governments. And you can see the LIDAR on top of the vehicle here on a tripod with magnets. And that's basically what the company needs to do, is to just drive along the road. Now I want to switch gear to security. We also use LIDAR technology fused with cameras to develop AI applications in physical security. And we have a platform that we refer to as iTrack. iTrack security platform also has one of our US patents. And I will discuss this some more. But basically in security, you are more concerned about people, not vehicles on the road. So our team have developed, just like we have developed the perception system for vehicles, we also have developed a perception system for humans, people, and crowd. And that detects people, enhances the detection to the point of tracking the people without a loss. And once you detect and track, you then are able to develop a lot of very valuable applications. Again, we see LIDARs, cameras, and computers. Nowadays, you have more and more cameras everywhere you go. Camera is the technology of tradition. Everybody loves cameras. We look at the video, we understand it, it makes sense. It shows us things we are familiar with and are very valuable indeed. So, but people are annoyed by cameras, and more privacy concerns are raised. So the combination of LIDAR and cameras allows you to minimize the use of cameras and depend more on LIDAR technology that does not record or invade people's privacies. So the first solution we have is called iTrack PRT. PRT stands for People Recognition and Tracking. I want to show you this video just to give you an idea how LIDAR detects people. These are people. These are people being detected and tracked and assigned unique IDs and having bounding boxes around each one of them. And now we're using them to deploy some virtual counting, accurate directional counting lines, or setting zones these zones will also have count of the people inside the zone all the time. So as you cross the line or as you get into the zone or leave the zone, these data will be collected immediately in real time and reflected in the application or on a dashboard. The other thing I want to say is pay close attention to this guy here and this guy here. This is ID 0 and ID 1. Most similar systems, when a person joins a crowd and you're detecting by LIDAR and you have an ID given to the person for tracking, once they join a larger crowd, you lose the ID, you lose your person. So if you're tracking a suspect, for example, at the airport, you will lose your suspect because of the confusion that happens when they get together. We have developed our perception system taking that in mind so that when two people embrace, like say goodbye at the airport or train station, and then they split apart, they don't lose their ID. So this guy here is ID 1, this guy here is ID 0, and they're going to hug each other. Watch. They're coming close, they embrace together as one box, and then they split apart, and they still kept their ID 1 and ID 0 without a fail. For people familiar with LIDAR technology, this would be extremely meaningful as it's significantly superior to similar such systems. That allows for accuracy. What is the difference between an AI company and another? Accuracy. The only main difference between two AI companies doing the same thing is the level of accuracy of the solutions they have, the algorithms they produce, and the neural networks they use. I want to show you this video. It's an animation, but it will demonstrate the message. This is an airport terminal. And in the airport terminal, we have deployed LIDARs, as you can see here, and cameras working together, calibrated and synchronized. Here, the camera performs facial recognition, and the LIDAR does people detection and tracking. And we'll see how the two work together with real-time exchange of data. First of all, we have a virtual line for counting. So we count the people as they come in. And then through facial recognition, we identify wanted people from a database or a blacklist, and then send an alarm to the authorities. And now the LIDAR, having been fused with the camera and having its perception system fused with facial recognition, is able to track that person, not an anonymous ID, but as John Smith, as an identified, recognized person. Wherever John goes at the terminal, whether there are cameras or not anymore, the LIDAR, as long as they are deployed in the covered areas, will always be tracking them with identity. Notice here that not only did we fuse LIDARs and cameras, we also fused facial recognition with people tracking. And that fusion resulted in a real-time exchange of data. And that is the heart of the invention. That is the heart of the US patent for PRT, or people recognition and tracking. And this way, whether there are lights or not, you are always able to track your person and display that on a tablet with the authorities. So here's the police officer holding a tablet in their hand, showing this screen with the specific location of where that person has gone. So you don't need to go and look for him where the camera alerted on, but you can go straight to him. He went to the restaurant, he's at the duty free, he's at the departure gate, etc. You know exactly where he's at all times. And now I will show you a real life example here from one of the projects in the region. You see, there is a mall. This is an area required to be secure. We have deployed LIDARs. This is the map of that area. This is the mall entrance. This is the mall entrance. And here is a cafe. Here is a restaurant. And here is another cafe. And this is a walk. People walk in that, going up and down the street. So what we will see here is people coming out of the mall, and because the camera and the LIDARs are fused together, the three people here we have in this test, Omar, Mohamed, and Asaf, coming out, they're all wanted on the blacklist. So the alerts will be generated automatically in real time, and the LIDARs will be tracking with the fusion, the AI fusion between the two systems. And then the tracking will appear here in distinct color code for every person. So watch when I play this video. Omar has come, the alarm is gone, he's being tracked in yellow. Mohammed has shown up, alarm is gone, tracked in blue, and Asaf showed up, alarm is gone out, and he's being tracked in red. And no matter where they go in the covered area, the movement will be displayed with coordinates, trajectory, and velocity wherever they go, so that you have a specific report of the people you're trying to identify to better extend security and protection to critical infrastructure that you are required to secure from any intrusion. With the help of facial recognition, you can also recognize dangerous people and report on them in real time. This video continuously repeats itself. You see them walking, being tracked. We also have virtual counting line in front of the mall for people in and out, and virtual counting line at the walking street for people going up and down. And you have a heat map that allows you to know where the traffic density is at in real time at all times. So this is eye track, people recognition and tracking. I may be too fast for a lot of you. Feel free to take a note and ask questions. I will conclude by this last solution that uses LIDARs, and it's called perimeter protection. You want to protect the wall, the fence of the critical infrastructure, of the airport, of the prisons, of the palaces, of government installations. Now, what do you use today is CCTV, cameras that are bringing video stream to a security room full of screens, and we have security personnel watching these videos for anything suspicious. Then they started saying we're going to use visual analytics on the cameras, which basically is object detection. They set detection zones along the wall, and then if there is any intrusion in or out on the wall, they will generate an alarm with the location. The problem, as we mentioned with visual analytics, is that they have some limitations because cameras have some limitations. The videos are 2-dimensional frames, so your detection zone is a rectangle, whether on top of the wall or on the side of the wall. And you are subject to lighting. So if you are outdoor, the sun position will cause a difficulty in the quality of the video, affecting the analytics. You have storms and weather conditions and dust and snow and
Mohammed, you seem to have.
Yes.
I'm not sure how I get muted, but can you hear me now?
Yeah.
So I was talking about the perimeter protection and the camera use, and why camera alone is not sufficient because they have limitations of the very technology of cameras. Have you heard that before? Did you all hear that, or should I repeat it again? I don't know where I was cut off.
Yeah, just about this CCTV cameras.
Right. So now they do visual analytics with cameras, and that has a lot of limitations and results in false alarms. Because when you use cameras, you have detection zones that can be triggered by a cat or a bird or some other tree branch, and the visual analytics may not necessarily distinguish clearly because of the video quality, because of the weather condition, the lighting, outdoor, dust, snow, rain, etc. So you need LIDAR, because LIDAR doesn't care about all that and gives you a 3-dimension output. So let's see how LIDAR helps in this case. I'm going to show you this brief video. This is when we were doing some tests. This video here shows the wall. This is the wall, the compound wall, and it's about 3-meter wall. We will see somebody running to the wall and jumping the wall. We have LIDARs. We have this LIDAR here. This LIDAR here deployed and is connected with a PTZ camera. The PTZ camera rotates in 360 degrees. So when you have the LIDAR controlling a PTZ camera, the LIDAR can direct the camera to rotate to the specific location of the intrusion that has been detected. And then the camera can record a video and images of the event. Let us see how that happens. Watch. This is a video. This guy is here running to the wall. Watch, he's running, he's jumping the wall. The LIDAR made the alarm right here and got the camera to record the image and videos and placed the whole thing into the alarm database. You can also see the same thing happening here. The person is running, is jumping, the alarm. This is the point cloud of the LIDAR. This is the detection zone. It's a 3-dimension detection zone along the wall. So it allows you with a lot more flexibility than a camera-only detection zone of 2 dimensions. And you ensure there will be no false alarm when you use LIDARs in that kind of application. Here's another video. As I mentioned, the PTZ cameras is a 360, so it could be looking, the lens could be looking anywhere. In this case, the camera is looking at the mall, outside, away from the wall. Watch what happens to the camera when the LIDAR detects an intruder jumping the wall. It will direct the camera to rotate straight directly towards the intrusion location to record the incident. Watch. Here is the person jumping on the wall. You can see it also here on the LIDAR point cloud. Then you have the alarm. Then you have the camera moving by the LIDAR control towards the location of intrusion so it can record and document in video and images the entire incident. And of course, the database will have all the associated timestamp and specific coordinate and location of the incident for the database and on-demand retrieval. So this video repeats itself, and you can see how LIDARs are extremely beneficial in that kind of physical security application. I think at this point should stop. I've given you probably a lot of materials. So my apology if you think that was too much in this session, but I'm always delighted in these kind of events. I am honored and privileged to be invited to this program, and I am a fan of sharing knowledge. I like to learn a lot and read a lot and watch a lot. And I also like to share the little bit that I may know. So at this point, I want to thank the organizers. I want to thank you for your good listening, and hope to have a chance to answer some of your questions.
Thank you very much, Mohamed, Sadek. It was really insightful, very interesting, and the best part of this is that it was you had lots of animations and videos to share and talk about. We have a tremendous number of audience. Around 135 people are right now online, and they are benefiting out of the wonderful talk of today. Yes, there are lots of questions coming up, but as we can see, A couple of things which I thought we will be talking about, and one of them you already touched upon. It will be good to know about the ethical usage of technology.
Engineer Riasat, I can't hear you for some reason.
Uh, I think it's muted. Engineer, yes, yeah.
Muted. Anyhow, the question was on the ethical usage of technology. How do you see the artificial intelligence and LIDAR technology? If how come it will be ethical usage of this technology? How do you see that, especially from the perspective that this technology is being used in security, and a lot of decision making is supposed to be made on this? So this is a general question, and of course we have got lots of other questions coming in from the audiences, and I'll be taking up one by one those of questions. Yes.
Yes, sir. That's an excellent question, and one that I have agonized over and thought about from the very beginning. You will never be able to totally prevent abuse, but what we have to do is we have to work on two tracks. Number one, you have to every company needs to develop its own AI code of ethics, how they perform their tasks in the area of AI, not just in security or where it relates to people, but even in the industry or in the banking sector, or where you deal with money, or where we deal with objects. To avoid abuse, there has to be a self-initiated set of ethics that companies have to develop, and but there must be also an international body of organization that somehow reaches out to each and every one of those AI related companies to achieve that objective. More importantly, I think government regulations, because laws are important. And more and more governments are becoming aware of the potential abuse of AI technology in all fields. And the UAE is definitely one of the leading entities in that regard, because they have had their eyes on AI for so long. So as they grow and proliferate AI everywhere, they are also putting together the legal boundaries beyond which AI needs to be regulated. So I think that will continue to grow in countries like the United States, China, India, everywhere, that where you have AI growing and getting its applications into everyday life.
Right. Thank you very much for that. Mohamed, it was interesting to see the video from the walk. And also I was happy to see Al Mulla Plaza, shown in Dubai. One of our audiences, he seems to be related to the marine industry. So he has a question, and it is, can LIDAR technology be used for seafloor excavation? Interesting. Can it go underwater or something like that?
Well, mapping with LIDAR technology is a very big industry within LIDAR application itself, because it's able to measure distances and depth and length and width and all different dimensions. And there are indeed devices that work underwater, made specifically for working underwater. Just like there are LIDAR sensors that are explosion proofs to work in specific environments. And yes, there have in fact been marine applications already developed. I think YouTube has a few videos of these. We in Com-iot have not yet gotten into that area, but definitely LIDARs can be used in so many ways underwater to map the floor and bring on very valuable data.
Right, great. Another question is regarding the system, whether it is used on a stationary platform or it can also be used on a mobile platform. Because what we saw is probably, you know, they were stationary devices.
I have shown P3, plug and play patrol. I have also shown iSlope, the angle measuring solution. So these are mobile systems. We place the LiDAR on moving vehicles. We have tried them even up until 250 kilometers per hour. So, and actually the algorithms are different so that you maintain point cloud stability and enhanced detection in full motion. But of course, it works just as beautiful from a stationary unit and from a moving train or a moving vehicle.
Mm-hmm. Well, okay. What we saw today during your talk is a lot of this technology utilization or the use cases seem to be with the government and police and you know, these agencies. Of course, they do have you know, a lot of budget to do that. One of the audiences is interested in knowing how does the operating cost compare between road traffic monitoring versus human tracking system? So how do you look at it from the costing perspective?
What we are realizing is that LiDAR technology's affordability is becoming much more affordable every day. When we bought our first LiDAR sensor, it was $10,000. The same sensor now can be brought for $2,000. And that's just in the span of 2 years. I think LiDARs will become at similar price as cameras very soon. They will be much more affordable. Now they're coming with iPhones, of course, the different applications, but they are becoming less expensive every day. And we have a good relationship with LiDAR manufacturers. We put a lot of pressure on them to bring the price down because we understand the value they bring, not only to the government, but also to you and me, to retail companies, to small shops, to everybody. That value of that technology can bring in an immense amount of application that can make our lives a lot better and easier and simpler and get us to achieve more. So they are coming down in price.
That's great. Yeah, I was looking at a Gartner study in 2019 CIO some survey, and I had seen that you know, between 2018 and 19, the organizations those have deployed artificial intelligence. Of course, LiDAR is an AI associated technology. So they grew from 4% to 14%. Which simply says that you know, it pays by itself, right? If you deploy the technology, definitely it's you know, it's paying
No
back.
doubt, there's no doubt. It automates a lot of the activities, saving time, cutting costs, and in some cases increasing revenue. So absolutely.
Yep. Again, it's similar to the earlier marine type of question, which you know, which is again talking about exploring the seafloor and substantial depth and or shipwreck. So, can the LiDAR technology be used, you know, in exploring the shipwrecks?
I am sure the day will come when that is established. For LIDARs to go down in very deep under a lot of pressure, I think the manufacturing has to take a lot of other elements into consideration. And so I don't have an answer. I am almost certain that this will be the case, perhaps in the near future. But the type of devices I have seen and dealt with are the ones that we use indoor and outdoor in everyday life. There are a lot of uses, obviously, from drones, but those are not much different from what we do. And then underwater, with the condition underwater, I think that is just a matter of time.
Great. Okay, there is one more interesting question, and that's especially again related to the road safety. The question is that since the major cause on road accidents is sleep disorder like narcolepsy, whether LIDAR can play a role apart from camera and rapid eye movement.
Yes. So the fatigue or drowsiness or sleep, we have a solution. It's actually a camera-based solution, not a LIDAR-based, and it detects the movement of the eyes. And it's made for companies that have trucks and buses or fleets of vehicles, and generates an alarm to the driver to wake them up. It also sends an alarm to the management so that they can be notified. For LIDAR to detect a movement of cars, there are LIDARs that are made, not the ones we have seen and dealt with today, but there are LIDARs that are made for the millimeter type detection. I don't know if they can be used for fatigue and drowsiness detection. Quite honestly, I think this is something cameras is much more experienced in, and in a controlled environment, indoor, inside a vehicle, that is the right solution to go.
Right. But we have one more question. How capable is LIDAR's security system? I think we saw some of the examples, but somebody wants to know more about the security system.
Yeah, you see, in terms of security, I always like to say this example. When do the criminals perform their crimes? They do them at night. They do them in the dark so that no one can catch them, no one can see them. This is when they go rob shops and banks and wherever. And this is where LIDAR is master, because LIDAR does not require any light. You place the LIDAR there in the depth of total darkness, and the LIDAR will detect and generate an alarm, and no one will see it. So LIDAR is perfect for security, whether it's private or public, indoor, outdoor. I am a fan of LIDAR in security.
Definitely. We have interesting audiences also, and some of them want to really trick the radar. If somebody is in a hurry, can it be tricked? You can bypass or avoid it.
I don't know. LIDARs are pretty meticulous because they are 3D devices. So they are gonna catch you. In cameras, for example, let's look at this scenario. A camera is looking at your face to identify if you're a wanted person or not. All you need to do is to cover your face, and no camera will recognize you. You just cover your face or change your face or disguise your face. Whereas a LIDAR is not looking at your face, but is detecting you as a person. So you cannot hide. You cannot be occluded, as we have seen. You cannot be obstructed from a LIDAR. It's a 3-dimension. It has a bird view. It will get you. So it's going to be very difficult.
Good. Now, there is another question which talks about the human safety. I don't know what frequency or what type of technology is being used by LIDAR But is it safe for humans, especially the long exposure?
Correct. No, all these LIDARs are approved by the governments. We use LIDARs manufactured by the United States and Canada, and they are all certified for human use. They are safe. We have all the certificates and data sheets. So yeah, they're perfectly safe for long-time exposure. Really okay.
Yeah, so in general, like these days, we are into augmented intelligence as well, like especially in which the people and AI are working together. How do you see this technology, being used as augmented intelligence?
Well, I see the human intelligence and the artificial intelligence going side by side and growing in use cases and applications. And I see that the fact that AI is automating a lot of what we manually do today is going to allow us to innovate even further and get the human intelligence to play an even bigger role. So I do not see a competition. I see a collaboration. I see a continued augmentation, as you mentioned, and I think the future is bright. I really do.
Yeah, so that can be a very good, information for our students who are right now watching this webinar and this talk. There is a scope for them to join this race or this technology, and especially the coming times, they will be definitely demanding and asking for more resources to support this technology and
Absolutely.
requirements. And
It's the fastest growing field today, anywhere, everywhere, is the field of AI and big data and data science. And there will always be room for these talents and skills, definitely.
Mr. Mohamed, if I may, although it's a bit outreach for me in terms of the understanding of the hardcore technology behind LiDAR, because purely I'm from an application point of view person. I think it was last year, the Elon Musk from Tesla Group had commented, and that's where I had some remembering of. He commented on LiDAR technology, and there was also in Technology magazine that they had adopted a different version of LiDAR. Are they using their own, or are they duplicating what LiDAR technology had already achieved, or is it something which they were not really accepting the fact on the advantages of the technology?
Right. So I think Elon Musk's comment was about not using LiDAR at all in autonomous driving for Tesla, and just depending on the use of a lot of cameras. The use of a lot of cameras in many ways with the right applications and algorithms can go a long way to compensate for the missing dimension that LiDAR produces. And his concern was commercial. He wanted his autonomous driving Tesla to be as low cost as possible so that it can sell and be affordable to more people. Now, when he said that when LiDARs were much more expensive than they are today.
Yeah.
And little he knew that LiDARs are coming down in price significantly. But the fact remains that aside from Tesla, everybody else, and I mean by that every other auto manufacturer, from Mercedes to Toyota to Lexus to Volkswagen, to new car companies that have just been formed for autonomous vehicles, such as Cruise and others, every single one of them agrees and uses LIDARs. Because as we have seen, it's a life or death situation. You want to be protected. You want to measure the distances with stationary objects and with moving vehicles and with people all along the way wherever you go. And you want to do that accurately. You want to do that with the highest precision possible because you want to be safe, not only for the people inside the autonomous vehicle, but also the people outside on the road. And the only way to have a high degree of assurance of that is the use of LiDARs all around the vehicle and deployed in certain ways that gives you that full coverage. And I agree with that.
Thank you very much, sir.
You're welcome.
Very interesting. I think the discussion can go on and on for hours and hours because the topic is so interesting and it's so exciting to know all this information. I think because of the time limitations we have, I'll be left with one more question to ask, and after that, I'll be asking Mohamed Al-Katheeri after this. So the last question is about the LiDAR reaction. It's again on the tailgating. When it detects cars tailgating in a slow-moving traffic, would it still take it as a traffic violation?
So if there is no moving traffic, no, because if you recall the way the tailgating violation detection formula requires the speed of the front vehicle and the speed of the back vehicle. And if both speeds are very low, below a threshold or zero, then there will be no tailgating violations to be detected.
Wonderful. Okay. Right. I think it's time for me to invite Mohamed Al-Katheeri. He's the Secretary of British Computer Society in the Middle East. He's the Vice President of IT in Adnoc, Logistics and Services. He's got around over 18 years of experience working in energy, logistics and shipping marine industry. He's skilled in IT, business relationship management, ERP support, business process development, data science, master in global leadership and management, and bachelor in MIS from UAE University. So over to you, Mohamed Al-Katheeri.
Yes, Assalamu alaikum, and thank you, Riaz, for the introduction. And thank you, Mr. Mohammed, for the very exciting presentation and informative. Actually, it was one of the most engaged presentation I have ever seen. It was really informative, and I believe personally I will benefit from it, and especially with regarding my future study in UK and the PhD in autonomous and vessels automations. And definitely I will maybe contact you soon to have an interview.
That would be my pleasure indeed. Good luck in your studies.
Yeah, so just as a close remarks, I would like really to express my great thank you on behalf of BCS and Mr. and Engineer Adil Al-Hashimi, BCS chairman, for Bolton University for arranging such as informative and engaged presentations and sessions. Actually, I call it the great minds come together and present the summary and the best of practices that has been presented in the market. I personally also felt mostly motivated and inspired by the speaker who's been invited in those webinars and the last 4 webinars, and inshallah we'll continue in doing such webinars And seeing that 130 participants, it's really a great, platforms to share such kind of knowledge. And I wish I was in, at the age of a student, I get the same level of informative information that can be get while you are sitting, relax at home, and listen to that. Thank you all, and I wish you a great evening.
Thank you very much.
Yeah. So thank you very much, Mohamed, for such a great talk and presentation. And thank you, Mohamed, and thank you, Satya ji, and all the organizers, especially Fatima, who actually is the person behind all this effort in organizing, and Shahid and Zahra. They have been.
She gets all the credit, Fatima.
Absolutely. I think
Thank you. Thank you.
it's because this is the last, isn't it last, Fatima?
Yeah. Yes, this is the last from this 4 series, but even our students and some of our colleagues also asking to continue. Inshallah, we'll try for the next semester because now all are busy with examinations and all.
Absolutely. And I was just about to say that, when you send me the invite saying the 4th and the last, and I said, no, it's never going to be the last. As Mr. Riasat Ali and Mr. Mohamed said, I think we need to congratulate and thank you and Shahid and every team at UOB RAK, because you are organizing these fantastic events and webinars, lining up fantastic speakers who are spending time. Evening in UAE is never easy to be stuck in front of a PC. If it was in England, then I would understand because it's cold out there, rain. But in UAE, you don't want to stay in front of a PC at 8 p.m. right? So it's as I said, we need to continue with this. So hopefully we can have more of a fantastic lineup of speakers and chairs as well. Maybe the next slot should be Mr. Riasat Ali. So he should be the main speaker, and we would like to hear from him in terms of AI and the technology aspects. So yeah,
you never know. Yeah.
watch out. Thank you very much once again, guys. And,
thank you very much from the University of Bolton, Al-Khaimah. Thank you for joining us and for all the support towards this session. Dr. Satya, Mr. Mohamed, Engineer Riasat, Mohamed Al-Katheeri, all.
Thank you. Great.
Thank you. Thank you.
Thank you very much.
Thank you all.
Have a nice evening, everyone.
Thank you, everyone. Have a good evening.
Bye.
Bye-bye.